Today, we are diving into one of the most mysterious, most fascinating numbers in the entire universe. Seriously, some people have even called it divine.
So think about this for a second. What on earth could possibly connect the swirling arms of a galaxy, miles and miles across, with Da Vinci's most famous painting and even the simple petals on a flower? I mean, it sounds like a riddle, right? But believe it or not, they all share this one secret mathematical connection.
And the answer is this, a single, pretty incredible number. It's known as the golden ratio, and we use the Greek letter phi to represent it. Its value is roughly 1.618. And here's the crazy part. Once you know what to look for, you start seeing it absolutely everywhere.
So to really understand the power of this number, we've got to get into what it actually is. It wasn't called the divine proportion for nothing. So let's unpack the math behind that very, very lofty title. Now, I know that sounds a little complicated, but the idea itself is actually super elegant. Just picture a line in your head. Now, you cut that line into two unequal pieces, one long, one short. You've hit the golden ratio sweet spot if the ratio of the entire line to the long piece is exactly the same as the ratio of the long piece to the short piece.
So if we just call the long part A and the short part B, the relationship looks just like this. It's this simple, perfectly balanced equation that gives us phi. It's like a point of perfect harmony that's literally baked right into the mathematics.
And our obsession with this number, it is nothing new. I mean, the ancient Greeks were all over it. You can see that with Euclid. Then, fast forward to the Renaissance, and it gets that famous divine proportion name. And, well, here we are, still totally fascinated by it today. But okay, this number isn't just something that lives in a math textbook. It seems to have left its fingerprint all over the real world. And it might just have its most impressive canvas in nature itself. You can find it in the graceful curve of a nautilus shell. Then you can zoom all the way out to a cosmic scale and see it in the arms of spiral galaxies. It's even been found in the very proportions of our own DNA. From flowers to pineapples, just like you see here, it's almost like nature has a favorite number.
And that, of course, raises a huge question. I mean, it's one thing for a mathematician with a pencil and paper to come up with a ratio. But how does the natural world, with no calculator, produce this number again and again and again in so many different places?
Well, the secret lies in another super famous pattern, the Fibonacci sequence. You probably know this one, right? You start with 1 and 1, and then each new number is just the sum of the two that came before it. Simple enough. But the truly amazing part is how it connects directly to phi. Okay, now check this out. Look what happens when you divide any number in that sequence by the one right before it. As you go further up the sequence, the result gets closer and closer and closer to 1.618, our golden ratio. This really simple additive growth pattern naturally leads right to phi. It's kind of mind-blowing.
So it seems like nature uses this ratio as a blueprint for efficient, beautiful growth. Which begs the question, have we humans done the same thing? And the answer is yes. It turns out we've been consciously using this very ratio for centuries to create things we find beautiful.
For ages, artists and architects have believed this ratio holds some secret to visual harmony. It's famously been said to define the pleasing proportions of the Parthenon. But this isn't just ancient history. As you can see, modern designers use it for everything from the logos for huge companies to, get this, the very dimensions of the credit card in your wallet. And a key tool for all of this is what's called the golden rectangle. It's simply a rectangle where the sides are in the golden ratio. But here's what's so cool about it. It has this property called self-similarity. If you cut a perfect square out of it, the smaller rectangle that's left over is also a golden rectangle. You can just keep doing that forever, and it creates this perfect, beautiful spiral.
All right, so whenever something gets this famous, you just know that myths are going to pop up around it. It's really easy to get carried away. So a huge part of understanding the golden ratio is learning to separate the proven facts from the popular fiction. So let's look at a few of the big claims. The Great Pyramids? It's a really cool theory, but there's just no hard historical proof it was on purpose. What about a universal formula for beauty? Well, some studies find correlations, but let's be real, beauty is way too complex and subjective for one number. And those nautilus shells?
Yeah, many of them are really close approximations, but nature rarely deals in perfect mathematical precision.
So here's the bottom line. While phi is genuinely amazing, and it really does show up in some remarkable places, we've got to be careful not to just see it everywhere we look. A lot of the popular claims are just a bit exaggerated, so it's always a good idea to be a little skeptical and, check the math.
So, we've looked at the math, we've seen it in nature, we've seen it in art, and we've talked about the myths. So, what does this all mean? What is the true significance of the golden ratio?
Ultimately, its real power isn't just about the number 1.618. The golden ratio is more like a bridge. It's a bridge that connects the cold, hard logic of mathematics with our deeply human, intuitive sense of harmony and beauty. It shows us that there might just be an underlying order to the things we find beautiful, whether that's a pine cone or a painting. And that leaves us with one last really big question to chew on. Is beauty itself a kind of mathematical formula that the golden ratio helps us see? Or are our pattern-loving human brains just naturally wired to find joy and meaning in a number that so elegantly balances the whole with its parts? The answer, just like the ratio itself, is beautifully complex.